Like the Chinese remainder problem, another important problem in number theory appeared in ancient China. This is known as the 100 fowls problem. A rooster costs 5 coins, a hen costs 3, and 3 chicks cost 1 coin. How many of each must you buy to get 100 birds for 100 coins? Variations of this problem appeared in India, Islamic, and European texts. While most texts gave specific solutions, only Leonardo of Pisa explained the solution in his Liber Abaci. The problem corresponds to solving a system of linear equations, but since there are 3 variables, the number of roosters, hens, and chicks, and only 2 equations, there are an infinite number of solutions. Since it is assumed you can't buy a fraction of a bird, we need integer solutions. And again, since it is assumed you can't buy negative numbers of birds, we're limited to non-negative integers. So let x, y, and z be the number of roosters, hens, and chicks. Then we require a non-negative integer solution to, there are 100 birds, so x plus y plus z is 100. And at the cost of 5, 3, and 3 for 1, the total cost of the birds is also 100. If we multiply the second equation by 3, we can eliminate the fraction. And if we subtract the first equation, we can eliminate the z variable. And we'll remove the common factor of 2 to get an equation in 2 variables. So we can reduce this problem to finding integer solutions to the equation. Solutions to this equation correspond to solutions to the congruences, and so our solutions will have the form and if we substitute these back into our equation, we find and so the general solution will be, now we actually have a third variable. Since the sum of the 3 variables is 100, we can solve for that to get Now again, we do want non-negative solutions. So in order for x, y, and z to be non-negative, we require, which we can solve to get, so x, y, and z will be non-negative as long as t falls in the interval between 3 and negative 4/7, where this third requirement is already included in this narrower interval. And there are integer solutions in this interval. 0, 1, 2, and 3 will give us positive values for x, y, and z. And we could go ahead and generate those. If t is 0, we have, and likewise for the other values.